Thank you all for attending NetBeez's webinar today. My name is Jordan Scott. I'm an account manager here at NetBeez. Also with us is Panos Vouzis, one of our esteemed co-founders. Today we will be discussing VoIP as well as the impact of packet loss, jitter, and latency. In case you didn't know who we are NetBeez, a proactive network monitoring solution that can help you get ahead of any network connectivity issues so your end users can have the best experience possible. We deal with some of the top companies that use hundreds of agents to help monitor their branches locally as well as globally. And some of the top universities will deploy agents around all of their campuses to make sure their students will have the best network possible. We have been recognized as one of CRN's top vendors for 2017, as well as Interop, Best of Interop 2017. Some investors that have joined our journey are Y Combinator, Partech Ventures, as well as our local and very own Carnegie Mellon University. So let's take a trip down memory lane and talk about where VoIP has evolved from. A PSTN technology has been overbought liable for a very long time. However, it's had its drawbacks. Its dedicated lines can get very expensive when trying to scale. You know, the whole point of business, you start out small, you try to grow. So when you need to implement more, it can get very, very expensive. It is very difficult to bring up to date. And when you try to, again, very expensive. And as time went on and new technologies emerged, it was hard for PSTN to adapt. Years later, VoIP started to emerge as the favorite phone service. That's because it was based off the internet, so it had very low costs associated with it. Plus, it's very easy to scale and combine with other telecom technologies that have appeared along the way. A great example of that is the webinar you're attending right now, that it combines voice, video, chat, and a number of other functions that wouldn't be possible without VoIP. Now, I'm sure you're all very aware of how VoIP works, but just as a review, when two devices want to talk to each other, they use the internet to connect to a SIP server. This will start a process called signaling phase, or when the communication gets established. Now, when it's established, they drop the SIP server and they continue the conversation by using UDP. Once one of the parties wants to terminate the call, the connection drops and boom, call's over. So let's get to the reason why we're all here. Since VoIP is dependent on internet connectivity, the quality of VoIP can be impacted by three main things: latency, jitter, and packet loss. Latency, it's pretty simple. This is how long it takes for one packet of audio to travel from one source to the other. Typically, each packet will carry around 20 to 30 milliseconds of audio. Now, latency doesn't exactly affect the voice quality, but it will affect real-time communication. Just imagine if I recorded a thought, I want to share that thought with you. And then I proceed to email it. If now when you hear the recording, it will be crystal clear, but our ability to have real-time conversation will be hindered. Now, how much latency is too much latency, you may ask? That depends on the combined latency from both sides. Typically, if there is less than 150 milliseconds, latency is not that noticeable. 150 to 250, you may experience some issues, but you'll be able to still hold a conversation. Then anything 250 milliseconds and above, now that's very noticeable and very annoying. Jitter. Jitter is the variation delay of voice packets. For instance, one packet may arrive in 15 milliseconds, and then the second may arrive in 25 milliseconds. Dun, dun, dun. No, this can cause huge problems. As a result of high jitter, choppiness can occur. Now, as a sales guy that spends most of the time on the phone, we call locally, but we also call globally. So on top of trying to understand different accents, different lingo, trying to hold a conversation, when the phone cuts in and out, it makes it extremely difficult to do my job. So the lower the jitter, the better. Typical rule of thumb is if there's up to 5 milliseconds difference, it will be all right. Now, VoIP systems will try to take a proactive approach and typically include systems to try and reduce jitter, such as buffering and packet reordering. Now, last but not least, the last issue that can affect the quality of VoIP is packet loss. Now, this is a big one because if a packet is lost, then that means part of the conversation is lost. Since telephony is all UDP based, packets either may not arrive at the destination or they might get discarded if they arrive delayed or with errors. Optimistically, you'll have less than 1% packet loss, but because 3% and up, you will definitely notice a lot of issues. Packet loss can be mitigated to a certain extent by using technologies such as packet loss concealment. So now that you have all these metrics, how can you actually grade your VoIP quality? Mean opinion score. This is the main way to rate VoIP quality. Originally, the IT department would survey users on the experience of their phone services, and then they find the average rating. Typically, it's between a 1 to 5 rating, 5 being the best. Anything around a 3 or under usually is a bad experience, a horrible experience to be exact. But now as companies grow, that method of going around person to person, trying to survey them becomes highly inefficient. Thus, the MOS formula was scorned. Won't get into the nitty gritty of this, but if you were able to capture latency, jitter, and packet loss, everything that we just discussed, you can get your MOS. If you want to dig a little bit deeper into the MOS formula, you can check out our VoIP blog that we recently posted at netbeez.net. Now let's take a look at what metric may have the biggest impact on VoIP quality. Here you can see at 0% packet loss, this is what your expected MOS would be, given the results of the other metrics. With minimum packet loss, you do have some leniency with latency and jitter. So you can see you're allowed, up to 100, 150 milliseconds of latency and about 50 milliseconds of jitter. Now, let's throw a wrench into that and see what it looks like with a little more packet loss. There you go. Now you can see even if everything went to plan with zero milliseconds of jitter and 0 milliseconds of latency, with that 10% packet loss, you'll still be very, very lucky to have a MOS score of around the 3 to 4 range. Now, how can you monitor this to see how much packet loss, jitter, and latency you may have? Well, 3 main ways to do this are: 1, call center records. This is great for monitoring call times, drop calls, as well as duration of the calls. They can also help capture the MOS score after the call was made. If you picked up on that, the one big problem here is you get all this information after the call was made. So this is a pretty reactive approach. Second main way, packet capture. This is great because it takes a detailed record of all the packets that are being passed back and forth on the VoIP call. So you'll get maximum information. With that, you get maximum overhead. The last and preferred way to monitor your VoIP is active monitoring. This is great because it gives you 24/7 monitoring with balanced overhead. And you can do this by simulating calls across your WAN pretty frequently. By doing end-to-end simulated voice calls, it's a great way to constantly know your MOS score. So you're able to receive statistics and troubleshoot any issues before end users may have a bad experience. So imagine your CEO has a call with another important company in the conference room, hops on a call, and all of a sudden they start experiencing issues. Who's the one to blame? It'll be able to, once you know that meeting's coming up, check the VoIP quality and the MOS score of that particular network. Then you'll be able to troubleshoot if there's any issues before your CEO hops on that call. Now, VoIP end-to-end simulated testing is just a little bit of what NetBeez is able to do. We're also able to help monitor the bandwidth of those networks, because limited people being on the internet, and will limit certain bandwidth for your VoIP. As well as then we can also help monitor a lot more from our dashboard, which now Panos will do a demo of NetBeez VoIP testing, and just to give you an experience of NetBeez's dashboard and some of the other things we can do as well.
Thank you, Jordan. And I'm going to take over and share my screen here. And I'm going to show you in real time what this VoIP monitoring looks like on NetBeez. So this is our dashboard. Here you can see each one of these thumbnails represents an agent. And this is what just Jordan talked about. An agent is a device, it can be hardware, virtual, wired or wireless, that connects to your network at the access layer, exactly where your users connect. Imagine if you have one of these agents at each one of your branch offices, data centers, even cloud infrastructure. You are able now to place simulated call from one location, another location, and measure different metrics. And among them, of course, the ones that we are talking about today, jitter, latency, and packet loss. So let's see how this look like on terms of VoIP. So here you can see I'm having these two agents in our Pittsburgh and San Jose offices, and right now they're running a VoIP simulated call between them by using G711 codec. The duration of the call is 30 seconds. These calls run 5 times every hour. And on the bottom, we measure for each one of these calls, we measure what is the jitter. You see here in blue, in the second plot, the packet loss, and the latency between the two ends. And from there, of course, by using the formula that Jordan showed you earlier, we can calculate the MOS score. For example, you can see here that the MOS score is, in most cases, pretty solid here at 4.34%. And you see that the values of jitter is less than 3 milliseconds in most cases, packet loss almost 0 all the times. And latency is below or close to 100 milliseconds, not ideal, but again, doesn't really affect real-time communication too much. And as an example here, we can see that in this last run, actually, let me see here, let me refresh. So the jitter, the packet loss increased from almost 0 or below 1% to 3.34%. And although jitter and packet loss, jitter and latency, I'm sorry, were under normal values within limits, that increase in the packet loss decreased that MOS score from around 4.3, which is pretty ideal, down to 4.1. So this 4.1, most likely, again, it's an acceptable value. It's pretty good. It's above 4%. Nonetheless, imagine having like a more serious problem. You can very easily go and see where this problem is coming from. And again, the idea here is that you don't wait for your user to place the call, have a bad experience, and then report or open a ticket with you at the IT department. And then you have to go back and scramble and see what happened, when did he place the call, and try to figure out what affected his bad voice experience. By placing these simulated calls, you can see that we can 24/7 monitor voice experience even when users are not placing calls, be proactive about it. So we know about issues before even the users know about them. And more importantly, know the root cause of the problem. Is it jitter, increased latency, or increased packet loss that caused any bad voice quality? And with that, we are done with the main part of the webinar. Thank you so much for attending this. Here's our contact information. If you want to contact Jordan or myself with any questions, you can follow us on Twitter. If you want to have a public discussion. And with that, I'm going to move on to the Q&A section. So let's see here a couple of questions we have from participants. Okay. Okay, so somebody asks if you can do Wi-Fi to Wi-Fi simulated calls, and the answer is yes. So just summarize, the types of agents we have are wired, wireless, and also virtual agents you can spin up either in your data center or in your any type of cloud infrastructure you may have, Azure, AWS, or Google Cloud. And yes, we have wireless agents that, and of course the idea there is, of course, you can simulate voice quality on wireless networks. We've seen a great use case of that in the healthcare industry, where now all doctors, nurses have, even staff, right, have this VoIP device that I often see them hanging from their neck, right? They press a button, they talk to each other, and of course that's all VoIP. And of course, it's very important when nurses and doctors roam around the hospital to be able to have this easy conversation to each other, right? So with a wireless agent there, you can simulate wireless VoIP end-to-end quality on your network. Okay, another question here. What is the overhead of placing simulated calls on the network? Okay, yeah, good question. Of course, this is I would say a dummy, a fake call when an agent to an agent, right, talks to an agent to an agent. So I would say the bandwidth that each call consumes, like a single call, it's in the order of 50 to 100 kilobps, right? So in modern networks, that is not, I would say, like something that can break down your network or put a stress on your network. So placing a simulated call, it's something that it's not causing any real, I would say, interference with the rest of your infrastructure. But the important thing also to think here is that if you are not able to place one more call, that simulated call between two agents, that means that if a user was trying to place a call at that given time, you would have a very bad user experience, right? So in that case, you should be reaching the limit, the capacity of your voice infrastructure, and you should think about upgrading if you have too many users placing calls during your business hours. And the last question I see so far is, what's the most critical factor for VoIP? Okay, so all three are critical, jitter, latency, and packet loss. Any one of them, if it goes to a very high value, can drop, of course, your voice quality. But I would say one that is often neglected is jitter, because it's not always something we measure unless we have a tool that measures that, right? With latency, we are pretty aware of what the latency is between two locations. Packet loss also, it's something that we can easily and understand these days. Jitter is something that's often neglected, and it can cause like a very bad user experience if it has a very high value. I would say above 5 milliseconds. If it goes to 10, then you most likely won't be able to understand the other party. Yeah, and with that, I want to thank you all for attending our webinar. I'll be happy to follow up offline if you have any questions or comments about this webinar. And see you at the next NetBeez webinar. Bye.